Hi, my name is Mark from cenTex Photonics, and today I'd like to talk to you a little bit about our first product, the MSGEQ7 Breakout board. It's specifically designed to make it very easy for you to interact with music and sound in all of your Arduino projects. This is the MSGEQ7 chip from Mixed Signal Integration. It's a 7-channel graphic equalizer that, given an audio input, outputs a series of 7 analog values corresponding to the relative intensity of each channel range. The MSGEQ7 does its job really well, and it saves a ton of code in your program, freeing up important space for the rest of your project, be it lights, motors, or speakers. However, the chip does have several important downsides. One of the biggest downsides is the amount of space on a breadboard that its support circuitry can take up. You need 4 capacitors and a resistor, along with 3 jumpers going to the Arduino, and 1 jumper going across this capacitor to your audio input. Now this setup would work perfectly fine, but here at cenTex Photonics, we've simplified the matter for use in integrated projects. The reason we've elected to go with through-hole technology and dip packaging for the integrated circuit is because these chips have a reputation of having relatively poor quality control and relatively spotty supplier reliability. We wanted to ensure that every package that we shipped had the capability of being easily tested and replaced if it was not functioning. By using the dip socket, we're able to replace faulty chips with ones that are known to work. Additionally, this technology allows us to individually test every single breakout board in an actual audio responsive product. To set up the MSGEQ7, you're going to need a couple of different things. Of course, you're going to need your breakout board. You're also going to need a small breadboard, in addition to a microcontroller. For this case, we're going to be using an Arduino Uno. You'll need a few jumpers, and you'll also need some method of connecting to your audio source. I'm using this 2.5mm headphone jack to breadboard adapter that I built. However, there's a variety of ways that you can do this. First, we're going to apply voltage to the breadboard by connecting it to the Arduino's 5-volt and ground connections. After we've done that, we can connect our audio input, which in this case is going to be both the left and right audio channels, so I'll insert both the white and red cables into the in port of the breakout board, and connect the black cable from the headphone jack to ground, because we want to make sure that there's a common ground between the audio source and the device that you're building. Next, we're going to connect our output port to analog pin A0, finally connecting strobe to D2 and reset to D3. So now the breakout board's been set up, and all we have to do is plug in the Arduino and then plug this audio jack into the audio source. But first we want to go ahead and upload the source code. So next we're going to go ahead and upload our example code. This is code that's available in the description of this video or on GitHub. So go ahead and upload to it. So it's done uploading. Let's go ahead and start the serial monitor. And if I pause it here, you can see that we do have 7 numbers going across. This represents the low end of the channel range, or bass, and this would represent the high end, or treble. If I disconnect the audio cable that I had inserted there, touch it, you can see that just by touching it and adding my background body noise to the system. Now these values are values that you can use for anything in your project, but let's take a look at a little bit more concrete example. So what we have here is the same setup as before, except that we've connected a homemade WS2812B, also known as NeoPixel matrix, to it. And basically we've added a couple of libraries and functions that do some different things than our original program. First, we've included the NeoPixel GFX and Neo Matrix libraries, which are available from Adafruit. Additionally, since this has 11 channels, I've also averaged some of the channels out. So for example, our third channel is actually an average between channel 1 and channel 2. So let's go ahead and power it up. So as you can see, it's detecting some background noise just like it was on our serial monitor program. If I touch it, my body adds background noise, outputting the new signal. If I touch different parts of it, it impacts the output differently. Let me go ahead and connect this to a computer. One important thing to note is that you want to be familiar with whatever lights or motors that you might be using in your project before bringing this code into it. You want to know how to give values to your project before you start getting those values from the MSGEQ7. So this about sums up how to use this board. Thanks for taking the time to watch, and we're looking forward to seeing all the amazing projects that you guys can make with the MSGEQ7 Breakout board.